My name's Lucas Haig. I'm the Northwest Area Agronomist with K-State Research and Extension, and I'd like to thank you for joining me for this brief look at some of the work we've been doing looking at the in-furrow placement of urea products with wheat. Working with me on this project has been Alan Schlegel, our agronomist in charge at the Tribune Experiment Station, the Southwest Research Extension Center there just west of Tribune, and then Dorival Reyes-Diaz, who's our state soil fertility specialist and is based in Manhattan. Okay, so why are we looking at this? Well, traditionally, in western Kansas, we've put on pre-plant in with tillage, very often is anhydrous with a sweep operation prior to drilling. We've shifted over the years. A large percentage of our acres now are seeded with air carts as opposed to box drills. And so a question we continually get asked is, what about, we now have this capability of these carts, what about putting on some in-furrow urea? Because we know that having that some nitrogen available there early in the season is beneficial to promoting tillering, fall tillering, which fall tillers are our most productive tillers. And so could we use urea put on in-furrow with the seed to get some of that nitrogen we'd like to have? Currently, our recommendations allow for 20 to 30 pounds of N if we're operating in a 7.5 to 10 inch row spacing, but we're talking about N that might be coming along with your use of MAP or MES or 40 Rock or products like that that are going to be where that nitrogen is going to be in the ammonium form. We recommend no seed-placed urea due to the potential for seedling injury as that urea converts. However, we look to the northern Great Plains and up in the prairie provinces of Canada. Work up there indicates that some use of urea or enhanced urea products may be possible. So just a little bit about the work we did here in western Kansas as part of our study. This study was not designed to look at wheat response to nitrogen timing, source, or placement. We were really just wanting to look at what's the potential stand reduction and its effect on yield. So everything we did, all of these treatments I'm going to talk about, they all had a full nitrogen program on top of that in addition to our in-furrow urea. So the wheat should not have been nitrogen limited in any form. We were really just wanting to look at the injury piece of this, of having urea in the seed furrow. So we did this at 4 locations across the state. And so we did our key locations for this work were at Tribune and Colby and up in Rawlins County near Herndon. And then we also had locations in north central Kansas and southern Mitchell County near Hunter. Everything was done no-till at the western sites, no-till chem fallow. We were using bird. We were dropping just a tick over 1 million seeds per acre. And then at Hunter, our north central Kansas location, those plots were no-tilled into wheat stubble, and we were using Larry as the variety there. So we had all these treatments. We had 4 rates, and these are rates of nitrogen, not rates of product. So we were putting on 10, 20, 30, or 60 pounds of N. And then we were doing that using 3 different products. So ESN, the polymer-coated urea, a NBPT, NPPT coated urea. So Limus was the actual commercial product that we were using. And then just straight commercial urea. Along with that, we also had 1 treatment of MAP, 1152O, and we were putting on that to get 10 pounds of N. So in other words, 91 pounds of product. And then we also had, obviously, a control where nothing went on in furrow. The first 2 years of the study, we were in 7.5s, and then I finally got my drill configured the way I wanted, and so in 2018, we were in 10-inch spacing. We tried to get fall stand count, spring stand count, head counts at harvest, and then grain yield and protein at all sites. These just happen to be the details of the statistical analysis we ran on it. And interestingly, just visually, we could pick out some of these differences from time to time. Not sure how well this shows up on your screen, but this happens to be Mitchell County in February of 17. On the left here, this is where we had put 60 pounds of urea in furrow. And on the right-hand side is also 60 pounds, but put on as ESN, as a polymer-coated slow-release urea. And certainly we can see a visual difference there just in terms of the stand reduction that happened between those 2 treatments. Okay, what about stand? This is averaged across 8 site years. This is in hundreds of thousands of plants per acre. Remember, we dropped just a little over 1 million plants per acre. So by and large, we're talking about final or fall stands in that 80 on our control treatment here. We're basically talking about 85 to 90% of our dropped seed is what we actually got up for a fall stand count. So interestingly here, so here's our control with nothing placed in furrow. And then here is 10, 20, 30, and 60 pounds of N, and then either as ESN, NBPT, or straight urea. And so really we don't see a lot of difference at the 10-pound rate, really no difference in fall stand amongst these three products or relative to control. Now by the time we're up to the 20-pound rate, when we're looking at the NBPT and the straight urea, we're now significantly less stand than our control. You can tell our control here has the A on it. These are group B, C, and D, which means they are significantly lower than our control treatment. So some stand reduction showing up there. And then by the time we're to the 30-pound rate, we're giving up stand in all three of these products, regardless whether it's ESN, NBPT, or urea. And then certainly at the 60-pound rate, we can really start to see things break apart. We're down here in our 60 pounds of straight urea, somewhere in the neighborhood of a 35 to 40% stand reduction. Here's another way of looking at it, just along with the rates. So here we go, 10, 20, 30 on up to 60 pounds. The blue triangle is the straight urea. The green block is the NBPT treated, and then the red circle is the ESN urea. And so you can just kind of see as we go by rate, you'll start to see these products start to separate out more at the higher rates, especially looking at urea versus the ESN. Okay, here we are looking at winter wheat stand at green up. Really not a lot of difference between the 10 and 20 pound rates. By the time we're up to the 30 pound rate, we can now see that the ESN has a fair bit more stand than either the NBPT or the straight urea. This is percent of control. So here we are, our ESN, a little over 90% of our control. So even then, we're taking just a little bit of a hit. And then obviously, again, by the time we're at the 60 pound rate, we see these three products really separate out. In our ESN, we're sitting at about 86, 87% of control, all the way down to our straight urea, which is only about 66% of control on our stands at spring green up. One thing we saw that we weren't necessarily expecting, and we've seen this at Tribune in 2016 and at Herndon in 2018, and that is the impact on heading date. And so if you look at our control here, this is day of the year. So in our control treatment, most of that headed between day one, really right around day 140. And if we look at the other extreme here, our straight urea treatments, most of those were heading out somewhere between day 143 and 144. So basically delayed heading date by about 3 to 4 days in there. And so if we think of what's happening, what we're really doing is this is injury to our fall tillers or injury to our stand that then is tried to, the wheat plant's trying to make that up with spring tillers. As a result, we have a lot more spring tillers out there, and so when we're looking at that whole plot, it makes our heading date appear later because we've got these later developing spring tillers. Now, the other part of that then is if we've got more spring tillers out there, they're later developing, they're probably going to be more subjected to heat stress. So does that show up? And in fact, it does. If we look at, this is kernel weight, which is a pretty good indicator of how much stress that wheat plant was under during grain fill. And not surprisingly, we see it especially here up at the 60 pound rate. Our lowest kernel weights are with the straight urea at 60 pounds. But we see that trend both between products and as we step down through the rates, as we burned off more of that initial stand, we got more spring tillers coming in. They're more subjected to heat stress, so we end up with lower kernel weights. All right, so let's get to the bottom line here, and that is what it do to us in terms of grain yield. So this is averaged across all 9 site years. You can see here our control, we averaged 69.7, just shy of 70 bushel wheat on the control. Here at the 10 pound rate, really no statistical difference here. So we could do 10 pounds of ESN, NBPT, or urea and saw no yield reduction, due to stand, so to speak. Again, remember that all of these treatments still had a full nitrogen program on top of it. So we're just really looking at the impact of stand injury from that in-furrow placement. By the time we're up here to the 20-pound rate, we can see the urea treatment now has dropped off, running about 4 bushel behind our control and the ESN or the NBPT. 30-pound rate, we see that separate out a little bit more. And then obviously by the time we're up to the 60-pound rate, things are sorting out a little bit. Now, so you might look at this and say, well, that don't look that bad. We can use some pretty high rates and not get away with it. What's made this research really challenging is you average it across the 9 site years, and this is the picture you get. But you have to understand there's a lot of year-to-year variability behind the scenes here, and I'll show one of those site years in a minute, where some of these treatments could be quite destructive to yield potential. And this is one of these examples, so maybe one of our worst case scenarios that we observed. So this is 2017 at Tribune. So if we look at our control here, making basically just shy of 45 bushel. Again, at the 10-pound rate, really no difference. Something odd here in the NBPT, and I've not been able to put my finger on what's really driving that. I think it's probably an artifact of the data. But we get up here to the 20-pound rate, then we can really start to see things break apart. So keep in mind our control's just shy of 45 bushel. Our ESN, 42 bushel, not statistically different, but our NBPT, now we're down to basically 40 bushel. 20 pounds of straight urea knocked us back to 32 bushel. So we're talking about a 12 bushel reduction there versus our control. And certainly by the time if we go clear to the extreme here, 60 pounds of straight urea, we're down to 22 bushel, so basically 50% yield reduction due to this high rate of urea applied in furrow. So you might not see that in the across years numbers. Here's 60 pounds urea. Well, that only set us back, about 9 bushel. But in some of these site years, a 60-pound rate of urea cut us by 50%. And so that's what makes this challenging, is there's a lot of environmental variability here behind the scenes. So in summary, what did we learn? In general, our data would suggest that we can do up to 10 pounds of straight urea in furrow. However, even at that 10-pound rate, at two of the 9 site years, so both Tribune and Colby in 2016, our yields were reduced by 7 bushel per acre. Now, that being said, that's when we were basically at around 100 bushel per acre yield levels. We've seen that 7 bushel reduction. And so that's a case where the environment was really beneficial to us later in the year. And so maybe even just a little bit of reduction in stand, we gave up that yield potential. But anyways, by and large, 10 pounds of urea in furrow seems to be safe. Across site years, our NBPT, NPPT coated urea did not reduce yields at rates up to 30 pounds per acre. In some years we did. In 3 of 9 years, though, that 30 pounds per acre would have reduced our yields slightly. Across all site years, ESN at 60 pounds did not reduce yield relative to the control. But again, there's a few years in there where it did ding. However, across all the site years, ESN at the 30-pound rate was never detrimental. We could use it at the 30-pound rate and never did see, in any of the 9 site years, never did see a reduction. There's potential for a seeding rate interaction in here, and I bring this up. This is some other work we've recently completed looking at seeding rate responses in western Kansas. And really my concern would be is you need to consider where are you on the seeding rate response curve already. We're seeing some pretty good responses to increase seeding rate, certainly as we go from 35 pounds, on up to 90 at some of these locations. But really, most of the time we're talking about an optimum somewhere between the 60 and 90 range. But if you're already down here planting 45 pounds, or even if you're only at the 60-pound rate, now giving up any bit of stand due to that in-furrow placement of urea, giving up any stand to injury, you're on a steeper part of this curve here. And so the yield penalty to having some in-furrow urea is going to be much greater if you're at the low end of seeding rates than if you're already up here at or near the optimum seeding rate. So our conclusions, ESN, NBPT coated urea provides some safety over untreated urea when we're using it in furrow in western Kansas. I'm not sure we have enough site years to truly evaluate the various risk levels, but from what we've seen so far, I feel pretty comfortable with saying that rates of 10, 20, and 30 pounds per acre for urea, NBPT, and ESN appear to be safe in the vast majority of instances. And so if you're looking for a way to spike your in-furrow fertility program a little bit, I think these are rates a person can feel pretty comfortable with, especially if you're operating towards the upper end of our seeding rate responses. Okay, and that concludes what I had to share with you today. There's my contact information if you have any questions or would like to discuss this further. And I thank you for your time.